Well, now we are starting our discussion on the various parts of the concept of waves. When we use the term waves, we are referring indirectly to energy. That is how energy propagates in a medium. Then we have to specify the medium also, whether it is a solid medium, the liquid, or the gas medium. And accordingly, we have to classify the wave. So, our discussion is waves and the classification of waves. First of all, we come towards the wave theory. Like, for example, all energies are in the form of wave, whether it is heat energy, it is light energy, electrical energy. So, all types of energies are generally in the form of waves. And waves are normally not visible, but their effects are visible. So, if we proceed in heat energy, we find that we are not in position to see heat energy or light energy or magnetic energy, any type of energy. We can't see, but their effects are visible. Like, for example, in the case of heat energy, conduction, convection, and radiation are the effects. Whereas in the portion of sound, we find that the sound is produced and that sound through the molecules or the atoms of the medium reach to the eardrum, and eardrum begins to vibrate, and that those vibrations are communicated to the sensory nerves, that is the brain, and we come to know that we are listening. Now normally when we speak of air, that will be longitudinal vibrations. So, in the wave theory, first of all, we have to go through with what basically is a wave. So, regarding wave, it's quite simple. We take a container having water or a pond in which there is a lot of water, and we throw a pebble on the surface. We find that the point where the pebble will strike, the ripples will be produced, and ripples are supposed to be moving outward, and to see this we consider a leaf and we place it on the ripples. So our observation is that ripple is moving in to and fro direction, but actually we are finding that when we speak, when we place leaf, it is basically vibrating to and fro about the mean position, and energy is transferred, that is at right angles to the particle motion. And similarly, if the wave enters the bulk of water, we find then it will become longitudinal wave. So basically, is wave motion is basically the disturbance produced in the medium by to and fro motion. So in the wave theory, we have to go through the modes of energy transfer. Particle motion. When particle is transferred from one part of the space to the other, it carries energy with it. So energy is the capacity of doing work. So some work is done in the medium. So particles are transferred from one part of the space to other, and they carry energy. Now we come towards wave motion. Normally, wave motion means that disturbance produced in the medium by to and fro motion of the particles. To and fro means back and forth motion. So the main context is when no particle is transferred from one part of the space to the other, although energy is transported. And that energy performs the work, and work is obviously force into displacement. So when this energy is transported, it will exert force and will cause displacement to that portion where this energy has been transferred. Now we come towards the classification of waves, that is the various types of waves. So there are a lot of waves. Normally, one of the waves is called electromagnetic wave. It's a very special case, but otherwise Sound waves are normally longitudinal waves in air medium. But sound waves are supposed to be transverse waves on the surface of water or on the surface of solids or surface of liquids. But when they go in the bulk of the material, they become longitudinal waves. So when we use the term electromagnetic waves, uh, we are referring to such waves which constitute electric and magnetic field, but themselves they are not deflected by electric or magnetic field. So in our main context, electromagnetic waves, that is EM waves, medium is not necessary for the propagation, but for the mechanical waves, we find that medium is necessary for the propagation. When we use the term mechanical waves, we are mainly referring to longitudinal waves because they move in the form of compressions and rarefactions, whereas electromagnetic waves move in the form of crest and trough. So, some important points regarding the electromagnetic waves is that they produce the varying electric and magnetic fields, but they are not deviated by electric and magnetic field. Moreover, electromagnetic waves are indicated in three dimensions on that is three dimensions. The x-axis or y-axis will indicate the electric and magnetic field, the oscillating electric and magnetic field, and the propagation will be indicated on the z-axis. All the three axes are mutually perpendicular. And another thing which is important, electromagnetic waves are basically transverse waves and they do not require material medium for propagation. When they come from sun to earth or in the space, they move without any medium. That is, they can move in space, that is in vacuum. Moreover, electromagnetic waves are constituted of photons according to Maxwell, and energy of that photon is taken as h nu or hc over lambda. The momentum of electromagnetic waves is normally p is equal to h over lambda or it is h nu over c. Another thing that they move with the speed of light, that is 3 multiplied by 10 to the power 8 meters per second in air or vacuum, that is free space. And this velocity we calculate by using Maxwell equation because these waves were first of all mathematically predicted by Maxwell. The formula according to Maxwell is C is equal to 1 over square root of epsilon naught into mu naught. Epsilon naught means absolute permittivity of the medium and mu naught is absolute permeability of the medium. So if this value is put in the equation for air medium, the value comes to be 3 into 10 to the power 8 meters per second. The another thing important regarding the electromagnetic waves, that is electromagnetic waves, they are of different types. Like for example, some waves are called the radio waves, other are infrared, then another category is visible light, then ultraviolet, then comes after ultraviolet X-rays and then gamma rays. Some of the electromagnetic waves, they exhibit the phenomena of photoelectric emission, especially in case of light and ultraviolet light. We can observe this type of phenomena, but frequently we observe it in ultraviolet light. Now, another thing is that electromagnetic waves, some waves like infrared waves, they generate heat. So they are generally used for removing fog uh, when during the aeroplane landing or takeoff. So these are some important facts about the electromagnetic waves. They are transverse and they move in the form of crest and trough. So the very important thing to understand is they generate the varying electric and magnetic fields and the propagation is always on the third axis. So what is the main concept? Electromagnetic waves, the medium is not necessary for the propagation. Now we come towards the periodic changes. So it is one of the part of the electromagnetic wave. Periodic changes take place in electric and magnetic field. Hence, the name of this wave is electromagnetic wave. In medium, electromagnetic waves travel with the velocity of light. This is what I have just now explained in my discussion. And electromagnetic waves can be polarized. Polarized means that they take the shape of transverse vibrations. For polarization, we find electromagnetic wave is passed in a Polaroid. Now, electromagnetic waves, as I have explained earlier, are transverse in nature. They move in the form of crest and trough. Medium is not required by the electromagnetic waves. Basically, they are photons and they do not carry charge. So, electric and magnetic field produced by electromagnetic waves, they do not affect the deviation of photon because photon do not carry charge. And the formula of electric field is that is F is equal to EQ, and the Q is not existing. Whereas force due to magnetic field is given as BQV sine theta, and theta can be taken as 90 degrees and charge is 0. Your force due to magnetic field will be 0. Now, rest mass, when we speak, there is an equation of the rest mass, that is m naught is equal to, or m, that is the rest mass will be m. However, the equation is m dash is equal to m naught over 1 minus v square over c square, where m naught is supposed to be the rest mass and m dash is supposed to be the moving mass. And this rest mass equation is generally known as the Einstein equation of the special relativity. So, the concept is rest mass of electromagnetic wave is 0, but it has relative mass and momentum. So mass is in the form of energy and momentum is h over lambda. So there are two types of physics we have made. That is the earlier part, that is earlier than 19th century. That part was classical physics, and all the formula, all the concepts are explained in terms of mass and inertia. But later on, it is proved that mass is convertible to energy. Therefore, the modern uh, concept of physics is based upon that is the quantum mechanics. All results of the quantum mechanics are in the form of Planck's constant, and the value of the Planck's constant is 6.610 to the power minus 34 joules second. And the dimensional equation of the Planck's constant is the same as that of angular momentum. Now, there are certain examples of the electromagnetic waves. One of the example is radio waves. Other example is light waves, thermal radiations. Thermal stands for heat radiations, and light, which causes reflection and refraction, diffraction and polarization. And radio waves are used for radio communication, that is, sending the audio signals to the long distance with the help of a phenomenon called modulation. And when it reaches to the receiver, there the demodulation is carried out and radio wave is rejected to the atmosphere, whereas the audio signals are passed into the amplifier.